function is positive when the function itself, which is graphed, is above the x-axis. So that's going to be here and there. I love that. Here and there. The number's right. So we're okay with that. Negative infinity, negative 3. Nice. And then everywhere else it's going to be negative. So are we okay with those pieces?
Yep.
Okay. The derivative being positive is where it's rising from left to right. Rising from left to right. So that's going to be from negative 2 all the way up to, you see how it says 2.2 right there? I would give you, if you said negative 2, or if you said 1 instead of, 0.75, sorry. If you said 1 instead of 0.75, I'd be okay with that. What I might do to get consistent answers, what could I do? I could label the highest and lowest points. I could do that theoretically. So based on what's on this, it's saying that that point right there is what? Negative 2, comma like negative 3. And what's that point right there said to be? Something like what? 0.75, comma like
6.2.
6.25? Something like that, right? I could label those points on the test to make it more consistent. If you said 1 instead of 0.75, I wouldn't take off points for that. You'd have to be further off. So what about everywhere else? The derivative is either 0, positive, or negative. So you know it's negative at the highest and lowest point. So everywhere else it has to be what? Negative. So you know the derivative is negative right here. There's where the derivative is negative. What about the second derivative? What do you examine when you're examining the second derivative?
Acceleration.
That is acceleration if this was position function, right? But structurally on the graph, second derivative positive means what?
Concave up.
Concave up. You're positive, it's concave up. So where is it concave up? It looks like it's concave up all the way to there, to that point. Because what happens after that point?
Starts transitioning into
To concave down from here. So that's concave down, and the red is concave up. That's where it comes from. So we actually, if I gave you the function, let's say this was a polynomial, what's the derivative at the highest and lowest points? What's the slope of the tangent line at the highest and lowest points? 0, right? So could you theoretically, we haven't done this yet, but could we theoretically find those points if I gave you the function?
Yeah.
Sure. Where the derivative is 0, highest and lowest points. What is this point right here? What's happening here? We have a name for this type of point. It's called a point of what?
Interruption.
Interruption.
Interception.
Today at lunch I was trying to say disposed. Someone is disposed to do something, and we kept on saying dispossessed instead. It's not the same thing. So, point of inflection. It's where concavity changes. So if these points are where the first derivative is 0, what do you think happens there? It's where the second derivative is 0. This is where the second derivative is 0. You will be doing that, finding this point exactly, finding that point exactly, finding that point exactly. But what do you have to have first? The function. You don't have the function, so you can't find it. You can estimate it. That's the best you can do. Do not obsess over the accuracy of estimates. Don't sit there going, is it 0.92? It's like when I ask kids to draw simple graphs, and for a long time, what do you guys do? Oh shoot, there's 9. You don't need to do that. Like I'm not looking for that, right? I'm not looking for that. Okay, anything else from the homework? Yeah, what's the second derivative going to be? Can someone just tell me what the second derivative is going to be?
2x plus 1.
2x plus 1. So you guys factor this. What, x plus 3 times x minus 2? Do you guys that? So what's x equal? Negative 3 and 2. But do you know which one's a max and which one's a min?
No.
Not yet. So what do you plug into the second derivative?
Negative 3 and 2.
Yes. F double prime of negative 3. Yes. F double prime of negative 3 and F double prime of 2. Yes. Now know that the derivative is 0 at negative 3. And you also know, what's the second derivative at negative 3? Negative 5. Negative 5 is greater than 0 or less than 0? Less than 0. So what does that mean? What does less than 0 mean for second derivative? Concave what? Down. Concave down. So at negative 3, it's concave down. So what happens at x equals negative 3? It's a maximum. It's a maximum. So what is f double prime of 2? It doesn't have to alternate. You have to test both. F double prime of 2 is 5, which is what related to 0? What related to 0? So what is it? It's concave up. So what is it? What does that one look like? This one Looks concave up, right? So it's a what? Minimum. Do you have any idea what the y-coordinate is? No, because when you integrate, when you go back to the function, how many functions have this derivative? How many functions have this derivative? An infinite number. You can move it up or down. So do you have any idea what the y-coordinate is for the maximum? No. Do you know what the y-coordinate is for the minimum? No. But you know that at x equals -3, there's a peak, and at x equals 2, there's a min. Okay, let's keep going here. Let's keep going here. How do you find points of inflection?
It's like the middle of
It's going to be middle, but you can't average it because it's not necessarily going to be symmetric. Which function do you look at to find points of inflection? The second derivative. So you already found it. What is the second derivative, Natalie?
Of -3, negative.
No, of this, right here. What is it? Just
plus 1.
2x plus 1, right? The point of inflection occurs when the second derivative is equal to what? Equal to 0. We just did this. So what do you said equal to? Oh, 2x plus 1 is 0. So 2x equals 1, -1. So x equals? -1/2. So a point of inflection happens at -1/2. The definition that I need you to remember about a point of inflection is the concavity what? It changes. The concavity changes. Look what we have here. At -3, there's a max, and at 2, there's a min. So what is this thing going to look like? It's going to be cruising along. It's going to look something like this. What happens here? Well, that's x equals -3. And what's that value? X equals what? 2. And then what's the x value right there at the point of inflection? -1/2. Exactly. So you know to the left of -1/2, to the left, it should be what? The second derivative should be, negative because it's concave down, right? You see how it's concave down right there?
Yeah.
It's concave down, and then it changes to what? It changes to concave up right there. So you can actually see that a lot more easily than finding that graph because look at this function, everybody. 2x plus 1. Give me a number to the left of -1/2. Give me a number to the left of -1/2.
-1.
-1. Plug -1 into here. What do you get? Plug -1 into here. What do you get? -1. Is that positive or negative?
Negative.
Should it be negative? Yes. What's to the right of -1/2? What's the easiest number to the right of -1/2? 0. Plug 0 into there. What do you get? Oh, is it positive? Yes. So you can test it, and you're going to make graphs like this where you know that the second derivative at -1/2 is 0. Everywhere else it has to be positive or negative. To change from positive to negative, it has to be 0 first. We kind of okay with this?
Yeah.
Okay, let's do it. What? I want to show you this. You need to do this well. There's a lot to know, so let's focus on this for a second. One thing Arvin did I recommend is you're going to need, because we're looking for maxes, mins, and points of inflection, the first and second derivatives, so you might as well write them down. The first derivative is 3x squared minus 4x minus 4, and the second derivative is what? 6x minus 4. You'll need both of them. You need to keep track of what you are finding out and not mix things together. Mixing things together on this destroys you. Be careful. So it asks you for the maxes and mins. Your first target is what are the x coordinates for the maxes and mins. So yes, most of you figured out, I think all of you, that you need to set the derivative equal to 0. One of the jokes that I make is that if you're ever lost in calculus, any calculus class, take the function, find the derivative, set it equal to 0. You're going to do that so many times in your calculus career. It's the most common thing you'll ever do. It's super helpful. So you factor this and you probably got what? 3x, what? Plus 2?
Yeah.
X minus 2 equals 0. So you have x equals -2/3 and x equals 2. Those are the x coordinates for what could be maxes and mins. Could be maxes and mins, right? So how do you test to see if it's a max or min? You use there's two tests. We've learned one so far. We like the second derivative test, especially if there's a nice second derivative. Is there a nice second derivative? Yes. So we did f double prime of -2/3. And what'd you guys get when you plugged in -2/3? -8, I think?
Yeah.
And then you did f double prime of 2 and you got 8. So what does that mean? It means that this is going to be, so this implies concave what? Down. So this is going to be a max will occur there. It's not the maximum value. The max will occur there. And what will this be? A min. Because 8 is greater than 0. What does that imply? Concave what? up. So to find the y coordinates, you've done this a million times, not a million because that's like 12 days of your life. Well, maybe. You plug into the original function, which you guys were doing, and you beg to use your calculator, which is fine. Anybody find the actual y coordinates? So you know it's negative 2/3 something, and it's what?
Negative 2/3, negative 8 over 27, and 2 comma negative 16.
2 comma negative 16? That sounds about right. So we know that this is going to be a max, and this is going to be a what? Min. I think that sounds right. How do you find points of inflection? You set what equal to 0? For the second derivative. So that 6x minus 4 is 0. So 6x equals 4. So what does x equal?
4 over 6.
Which is?
2 over 3.
2 over 3. So that's the x coordinate of the point of inflection. To get the y coordinate, what do you need?
Just
2/3 comma, the function evaluated at 2/3, right? And that would be the point of inflection. So what do we now know? We can put this together and get the general shape of this. We know there's a max at this point, negative 2/3, negative something, right? And then what happens? There's a minimum. So where's our maximum? Right there. Where's our minimum?
right there.
Right there. And then our point of inflection,
Right there.
I love that general, like the number on the board. If we graph that, we should see something like that. To the left of 2/3, it should be negative, the second derivative, because it's concave down. To the right, it should be positive because it's concave up. But that's the general structure right there. Was there a hand?
Yeah, I just
Go
make
ahead.
sure that you're plugging the, after you set it to 0, you plug it into the...
Or x, yep, plus 8. And I'll do zoom. And what am I graphing right there? That's graphing the derivative right there. Remember that? Graphing the derivative. So this is going to graph the function in the derivative. So I'm going to zoom standard to this just to start off with something because I don't know where it's going to look like. Let's see what happens here. Oh, does that look like what we expected it to look like?
Yeah.
And then what's it graphing now? It's taking a second. What is it graphing now?
The derivative. but
Why
it's
does it take a long time to graph the
just
derivative?
graphing points.
It's just graphing points. It doesn't graph a function. It graphs points. Yes.
That doesn't look like the points.
We didn't get... you're right. So maybe, let's see. Let's do a different window here. So if I change the window, how about negative 3 to positive 3? Let's graph it like this. There's the function right there.
It's on 0.
It looks like it's on 0. So maybe there's some sort of... do the x values look okay?
Yeah.
Yeah.
The x values look okay, but it looks like Noah, you might have evaluated someone. Don't apologize. Totally okay. So let's take this and...
Okay. Marvin, you did the second half of it.
We are getting judgy. We're getting judgy here. Okay, so look, it looks like, so where's the original function? The function itself is this one, right? Hey, is that the right shape at least?
Yeah.
So that should be negative 2/3 comma something, and this should be what? 2 comma? It looks like it's 2 0, right? It looks like it should be 2 0. Let's see here. 8 minus 8 minus 8. Yeah, this is 0. Yeah, not that. And then this one right here.
It's like 9 point something.
Yeah, do you know how, by the way, let me show you something. If you guys, I'll show you, your calculator will actually give you a good estimate for that. If you go on your calculator, I'll show you this. You don't do it right now, but if you go to second calc, not trace, but second calc, sorry, let me go to quit here, not alpha. Sorry. If I go to graph and I do second calc, which function do you think I should use?
dx dy.
Well, that's derivative. I want to find the maximum, right? So what is it asking me for? Do you see what the question mark? What's it asking me for?
Left bound of the, what
You go to the left of what you think it is, right? So I'm going to the left, and what do I hit? Enter, and then what's it asking me for?
Go to the right.
You go to the right of where you think it is.
Doesn't it say to go as close as possible?
Yeah, it's okay if that's
Doesn't
close
really
enough.
matter, right?
And then you go for a guess. I'm guessing somewhere in there, and I hit enter. Look what it gives me. It's pretty good. Now, can I see, you see that decimal? That 9.4814815?
Yeah.
Let me show you something. If you go back to the original screen and you type in y, which is alpha 1, look what it has. It saves that as y.
Ooh.
It's pretty cool. So every time you do that, it'll overwrite the y. So you have to be careful. Like, watch this. I'll plug in any letter, like, I don't know, G. If it doesn't have a value stored, it's 0. So 9.48, 481, 481, 481, that's repeating decimal, right? So that probably means it's a nice fraction. You could plug it in and find out exactly what it is. But we got the decimal, so it's, was it 9.481? Sometimes, do you know about this button on your calculator? This is useful. If I plug in to fraction, do you know about that button?
Math, right?
Yeah, math, the first one. 256 over 27. If it's close enough, it'll do that. It's good. Okay, let's keep moving here. Let me pick a good one from the worksheet, right?
Yeah,
you know they occur
we
at...
answered that, so you have
Oh, you
3,
did?
3,
Oh, you
12.
did? Oh, cool. Okay.
That's why we were asking whether
Oh,
it's
3,
the,
negative 3, and what?
Negative 1.
Negative 1. So what are the 3 points? 3 comma what?
24, 12, and negative 8.
3, 24, 3 what?
12.
Negative 3, 12, sorry. And negative 1 what?
Negative 8.
Excellent. So those, you don't know yet if they're maxes or mins. Sorry, I didn't understand where you were. Excellent. So then you plug in 3, negative 3, and negative 1 into the second derivative to figure out if they are maxes or mins. So you take the x values, and you plug those into the second derivative. Yes? Yay, exciting. So that's concave what?
When we entered it,
Up, concave up, and this is concave what? So that means it's a minimum. That's a minimum, and this is a max. Yeah. The square root of 112 divided by what? 6, and store it as, I don't know, C. There's STO in the bottom left. So I'm storing it as, what? Alpha C. Enter. So I have those two numbers are saved. So what was the function? What was the original function? Can you tell it to me? What is it? What is it? Someone read it to me.
0.25.
Yeah, B and C. So plug in B, right? Sorry, I didn't type the word B. If I go to B, you gotta do alpha. So alpha B. And what do I get? That. And then I do alpha trace y1, and what do I plug in instead? C. You don't have to close it actually. So those are your two y values right there.
That was just plain simple. It's just